Okay, so this afternoon we want to look at how to manipulate or how to do certain calculations with 2D Numpy arrays, which are basically matrices. We have seen how to create arrays, whether it's a one-dimensional array, which is a vector, or it's a two-dimensional array, which is a matrix. We have seen how to do that. But there are certain operations which you can carry out on a matrix, and that's what we want to see. One of the operations we can do is something called flattening. When you flatten a matrix, a two-dimensional matrix, you're basically changing this matrix into a one-dimensional array. Another thing you can do with a matrix is something called a transpose, where you exchange the rows and columns. So you switch the indices, the position of the rows and columns, and you get something like that. Then you also learn how to create a complex matrix, a matrix which contains complex numbers, and how to obtain what's a conjugate. Then you also learn how to get the diagonals, the elements which are on the diagonal of a matrix. Then we also learn how to create a matrix, which is what we have done, an array, but this time we're going to use another parameter which is called data type, dtype keyword. Then there's something called typecasting, where you change what kind of information is supposed to be in an array. So we're going to see how to do that. So the first thing we need to do, since we are talking about arrays, of course we need to import Numpy. So here, so we import Numpy, then usually we import Numpy using the alias np, like this. Okay, so that's what you've done there. It runs. Then next we create a two-dimensional array A, or a matrix A, using this list of lists. So here you have got each list here representing a row in this matrix. So when you do that, so you've seen how to do that, and of course when you print this one, this is what you have. So basically, as you can see, this is a list of a matrix of what 0, 1, 2, 3, 4, 5. Then there's some numbers like that. Then basically that's what you have. So the first operation we want to do is, if you have a matrix like this, then you want to change this matrix into a vector, which is just one row. So this thing has got, it has got one first row here, second row, third row, fourth row, fifth row, sixth. So it has got 6 rows. So if you want to flatten this, make it flat so that it just becomes one row, there are a couple of things you can use. One of them is a function or a method called flatten. So you can use a method called flatten, and I think there's also a function called flatten. Okay, so let's start with that. So in this bit, so you're going to use a method called flatten. So we print out the matrix A. Now we're using a method flatten, so you're going to say A dot flatten. So when you do A dot flatten, so what you get is this. So you get an array of numbers, all the numbers, but they are no longer, as you can see, they are no longer being stored as a matrix, but now it's just a vector. So all the numbers get put in one row, and that's what you have. So that's what flattening is. Of course, the flattened, you can store the result of A dot flatten. You can store it in B. So this whole thing here, which we have obtained here, this can be stored in B, so that we have got a vector B holding that. So if you do that, then you print out B. This is what you have. So those are the values which you have there. So basically, this is what we mean by flattening. Are we clear? Is this clear?
Yes, sir.
Okay. Okay. So what you have here, if you change, next you want to see the A and B are not connected. So if you change, so when you flatten and store the flattened vector into, like in this case we've done into B, when we make changes to B, those changes we're making to B do not affect A. Are we clear? So in this case, we know that the first value in B is this one. So the index is 0 there, and the value is 0. So we change the the value which is the first one in B, we change it to 10 here. So this is what we do. So we're changing the value to 10. Then we print out B. When you print out B, this is what you have. So now we've got a 10 here. But when you print out A, this is what you have. The first value is still 0. So there is no connection between this A and the B. So you can make changes to B without affecting A. Are we clear? Is that clear?
Yes, sir.
Okay. Another way to do something which looks like flattening is to use a method called ravel. So to unravel an array. It's the same thing it's the same thing as flattening, but there's a slight difference. When you ravel your array, when you unravel your array using the ravel method, when you make changes to your B, the new thing, those changes are also reflected in A. Okay, so there's a difference. Here we have seen that when we made changes to B here, when you change the first value of B to 10, the first value of A remained unchanged. So that's what you have with flatten. With ravel, here we print A. Then if I say A.ravel, you see that it does something similar to what flatten did. Exactly the same, but there's a small difference. This A.ravel and A.flatten here, you can see it's the same thing. It's the same operation. It's the same operation there, which you have here, and what you have here. Okay. So if we store this, now the difference comes in here. If we store this in C, so A.ravel, we know it gives us this bit. Then we store it in C. That, then we display C, or we print out C, then we change the first value of C. We change the first value of C to 10. The first value of C is 0 here. We change it to 10. When you do that, then we print out C. You do that, then you print out A. You see that also the first value of A has changed. Are we clear? So there is this distinction here. When you're using flattening, when you use flatten and when you use ravel. The reason why this happens is because when you're doing this, nothing much has changed, but because the C, which you have changed here, is just the same as A in this case. Okay, but when you use flatten, you actually create a different vector which is not connected to A. So that's the first operation, which you can do with a matrix. You can flatten the matrix. There are two ways of doing that. You can use the flatten method, or you can use the ravel method. Are we clear? Is it clear? Is it clear? Okay, next we'll move on to how do you reshape an array. There are a couple of ways to do this. You can either use a method or you can use a function. So in this case, I print out A. So this is A. Then I want to see the shape of A. So A.shape, this is an attribute A, shape. A.shape will give me the shape of A. So this is a 6 by 6 matrix. So I can change the shape using the attribute. So A, I can do this, A.shape, then I pass the shape I want it to have to be a 4 by 9 matrix. 4 rows, 9 columns. Always remember that when you multiply these 6 by 6, that is 36. You can only change your you can only change the shape of your array to a product which is the same as 36. In this case, it's 4 times 9. That gives you 36. So you're using a tuple here to set the shape of this array. So you're setting it to a 4 by 9, like that. Then now you can print out your array A, and you can see that the shape has changed like this. You can also change the shape to a 9 by 4. There, 9 rows, 4 columns, like that. You print out A. This is what you end up with, like that. Then you can also reset the shape back to what it was, a 6 by 6. Then you can print out that. So basically that's what it is. So there's a way of changing the shape of an array by using the attribute shape and a tuple. In the tuple, that's where you put the dimensions of the array you're interested in. Are we clear?
Yes, sir.
Okay, so that's one way of changing the shape of an array. That's not the only way of doing it. There are other ways of doing it. For example, there's a method called reshape. You can use this. So here, I print out A like that. Then I say A.reshape. Now with this method, I put in the number of columns I want and the number of rows, 9 by 4. So when I do that, this is what I get. I can also say A.reshape 9 by 4 like this. When I do that, this is what I get. Then I can display that. So that's one way of changing the shape of your array. Okay, so 2 methods: using the tuple, the attribute shape with a tuple, or using the method reshape. Next, there's an operation you can do with an array, and this is what is called a transpose. Are you aware of what a transpose operation is? Where you switch the rows and columns, you interchange them. So in this case, this is what you have. This is our matrix. If you do a transpose, so this row is going to become the first column here. Then this one is going to become the second column. This one is going to become the third column. This one will become the fourth column. This one will become the fifth column. This one will become the sixth column. So these rows will become columns if you do a transpose operation here. So if you do that, if you run that, as you can see, so here, so this first row here, like I was saying, this first row here, 10, 1, 2, 3, 4, 5 is this one. 10, 1, 2, 3, 4, 5. So they become the first column here. This second row here, 10, 11, 12, 13, 14, 15. The second row will become the second column. 10, 11, 12, 13, 14, 15. This one, 20, 21, 22, 23, 24, 25. This third row will become the third column. 20, 21, 22, 23, 24, 25. 30, 31, 32, 33, 34, which is the fourth row, will become the fourth column. 30, 31, 32, 33, 34, 35. This one, fifth row, 40, 41, 42, 43, 45. Become this is a fourth row, it will become the fourth column. This one, 40, 41, 42, 43, 44, 45. And the last one here, the sixth row will become the sixth column. That will become, here we've got 50, 51, 52, 53, 54, 55. Then here we've got 50, 51, 52, 53, 54, 55. So this is what a transpose does. It switches the column, the rows in your matrix will become the columns. So the first row becomes the first column. The second row becomes the second column. The third row becomes the third column. The fourth row becomes the fourth column. The fifth row becomes the fifth column. Are we clear?
Yes.
Yeah. So this is one way of doing a transpose. If you print your A, you see that your A itself has not changed. So basically, it makes a copy. So this transpose method makes a copy of your array. Then it switches things and shows you what a transpose is supposed to look like. Another way of doing a transpose is by using an attribute. So there's a method, there's an attribute, you can use the attribute T, in this case. So if I print A, like that, then I say A.T. When I use A.T, So this a dot t, the t is the attribute, so it's going to switch the rows for columns. Like that. When you run that, this is what you get. You get the same thing. This first row, what was the first row is now the first column. What was the second row is now the second column. What was the third row is now the third column. What was the fourth row is now the fourth column. What was the fourth row is now the fourth column. What was the fifth row is now the sixth column, like this. Okay, are we clear?
Yes.
Yes. So basically, that's another operation which you can do. You can always store your transpose in some other vector. So in this case, I want to store the transpose in D. So the transpose of A, I want to store it in D, like that. Then I print out D. Okay, then I can change the values. The first value here, first row, first column, 0, 0. I change the value to 0. There, then I display D. Then I print out A. So what you see is I've changed the first value here, but also in A the value has been changed. So if you create a transpose, when you're creating a transpose of an array, then you change something in the transpose, that change is also reflected in A. Are we clear? Is that clear?
Yes, it is clear.
Okay. Next, let us see how to create arrays which contain complex numbers. So in this case, we have to use some attributes, real and complex and imaginary. So in this case, we say A. So this is our array A. Then we check the kind of data it has. So when you change the kind of data it has, so basically you see that it has got integers. Now, we want to create an array with complex numbers from this A. So what we're going to do is we're going to say A dot, we want to change the type of data A has as type. So we're going to change using the as type method as type. Then we want to say we want complex, we want data which is complex, like that. Then the result we're going to store in Z of this thing, like that. So now when you print Z, this is what you have. So you've got 0 plus 0j, 1 plus 0j. So you can see there's a real part here, which is this one. There's an imaginary part which moves with a j there. So basically, what you've done here, we've created an array Z, a matrix Z which is complex. If you look at A itself, A is still what it was. Okay. If you check the data type of Z, Z.dtype, now Z.dtype is going to tell you, oh, now this one is a complex. So it's got complex numbers in it. With a complex number, matrix a complex number, you can extract a complex matrix number has got a real part and an imaginary part. So you can extract a matrix of only the real part of this complex matrix. And how do you do that? You say z.real. So use this attribute real. So when you do that, so this is what you end up with. So you get this, you've got only the real part. Then here you can also extract the imaginary part, z.imaginary. When you do that, you see that your imaginary part has got zeros everywhere. So in this case, your imaginary part doesn't have much with it. So what we want to do here is we want to create a matrix, a 6 by 6 matrix, which we're going to assign to be the imaginary part of Z. Right now, there's nothing. It's just 0, 0, zeros. Okay? So, for us to do that, we're going to create a list of numbers from 0 to 35 using this arrange, np.arrange. I hope you remember what this does. Do you still remember what arrange does? Hello?
Yes, I do still remember.
Okay, so this np.arange is going to create a list of numbers from 0 to 35, 36 numbers from 0 to 35. Then after it creates and it's going to create not a list, an array of numbers, a vector from 0 to 35. Then those 36 numbers, we're going to reshape them into a 6 by 6. We're going to reshape them into a 6 by 6 matrix. Then that reshaped 6 by 6 matrix, that is what we are going to store as the imaginary part of Z. Are we clear? So here, so if you have np.arange, 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 what has happened? Where am I? Oh, no. So here np.arange, then I say 36. So when I run this bit, this is what it does. It produces numbers from 0 to 35, as you can see, an array of numbers from 0 to 35. Then after doing this, if I reshape these bits, reshape into a 6 by 6, 6 by 6, supposed to be a comma there. This is what I end up with. This is what I end up with. So those 36 values from 0 to 35, they get reshaped into a 6 by 6. So it's this reshaped 6 by 6. This is what we want to store as the imaginary part of Z. Since Z itself, its imaginary part has got zeros everywhere. We don't want to have zeros in that case. So in that case, with this, so when you do this, we run that, then we check what the imaginary part looks like now. Now it's no longer zeros, but it's got something like this. Now we can display Z, and you can see now the imaginary parts are not 0, but there's something there. And of course, if you check the data type there, then there's an operation you can carry out if you've got a complex matrix, which is called a conjugate. A conjugate of a complex number is where you switch the negative for the positive sign. Here, when you've got a complex number, when you're changing the sign of this, when you change, I think you change the sign of that. Let me see. Yeah, there's a sign change. I'm not sure if there's also a row change in this case. Let's see. There. Then the conjugates of this. Z.conjugate. So what is it? What's being changed? Yeah, so you're just changing the negative sign here. So all the negative signs, as you will see from here, they have been changed into, all the positive signs, pluses, have been changed into negatives. So basically that's what the conjugate does. So when you do this, you can save it into Z conjugate, then you display Z conjugate there, like that. Then you can find out which part is the real part, what's the real part of this conjugate, so that the real part doesn't change, but the imaginary part in this case undergoes a change. So now you have got your everything being negative. So basically these are some of the operations you can do with matrices. If you've got a matrix of real numbers, you can always do a transpose. In this case also, it's also possible for you to do a transpose. You can do a transpose with a complex, with any array, basically with any matrix you can do a transpose. But if you have got a matrix which contains complex numbers, you can also do a conjugate in this case. Are we clear? Yeah, so basically that's how you do it. Another operation you can do with an array is you might be interested in the diagonal. So in this case, we'll print out A. Okay, so you might be interested in these values, the 0, the 11, the 22, the 33, the 44, the 55. So that's the diagonal of your array. So in this case, A.diagonal, if you want to extract the diagonal values only, so you can use this method, the diagonal method. So you say A.diagonal, so with A.diagonal in this case, what you're going to see is that you get your 0, you get your 11, you get your 22, you get your 33, you get your 44, you get your 45, like this. So that's a diagonal bit. So you can use diagonal like that. In addition to that, you can also use diagonal with an offset. You can say you might not be interested in exactly this bit, the ones but you might be interested in this other one. You want to get the 11, the 1 here, the 12, the 23, the 34, the 45. So you set an offset value of 1. If you set an offset value of 1, then it's going to get the diagonal which is above the main diagonal like that. If you want to get something below, then you set your offset keyword to -1, and in this case, if you set your offset keyword -1, so you get 10, 22, 32, 43, 45. So basically that's how you would do your diagonal stuff like that. You can also do diagonal with a function. Usually these things are possible with a function. There's a function called diagonal here, so you can say np.diagonal a. So you need to do that. This is what you get. Or you can use np.diagonal a, then you can set an offset of 1. So you can do that. And also you can also set an offset of -1. You can do that. So you can do your diagonals with a method diagonal, and also you can do diagonals with a function diagonal. Okay. Are we clear? Yeah, there is this bit here, but fancy indexing, but let me see first. What's down here? Type custom. I think that this bit here, I think you can remove it. I don't think we need it too much. Okay, we can skip this bit. I don't think we need it too much. Okay, so the kind of arrays, you can create different types of arrays. You can have arrays which are with true or false values, or arrays which are with integers, or arrays which are with numbers or decimal points, or as we have seen here, arrays which contain complex numbers, or arrays which contain strings, or dates, or objects and stuff like that. So the different types of arrays which you can create. Okay, we want to see how to create arrays while taking into account that you want to create a certain type of array. For example, if you want to create a float or an array which contains floats, there, of course, you can be more specific about that. There are different types of floats you can create. As you can see here, there's a float 62, float 32, float 64, a float, a long float, and stuff like that. So basically, that's what you can do. So here, we're trying to create an array L with the function array, and of course if we're going to use array, of course you need to give a list. But as you're giving the list like this, you can also specify what kind of data you want to be contained in this array. So in this case, we're saying it's supposed to be a float 32. So when you do that, then you print out L, this is what you have. So basically a float is a number with a decimal point. So it's 0 point, 1 point, 2 point, 3 point. If you check out the data type, L.D type, in this case, L.D type, where is it? There, so you see we would float 32, then how many number of bytes each one has, that's 16. And you can change, again, you can create a float 64, this guy, like that. So you specify the data type you want to be stored. So we have done something similar to this when you're doing vectors or stuff like that, or array, two-dimensional matrices, matrices. But the difference here is you specifying what kind of information is supposed to be in this array, like that. Okay, so there doesn't seem to be much difference. But if you look at the data type has changed, and of course the number of bytes. Now you have got that. Okay, 32. You can also just get away with just saying you want to create a float like this, so that's also fine, like that. So then d type that. So basically when you just say float like this, what tends to be created is a float 64, and of course the type is that. You can also, if you have created an array, you can change certain things. You can change using you can change the type of data which is in an array using a function called I think last time as array. Yes, as array. Okay, so you can change the type of information which is in an array which has already been created. Okay, so in this case we create a float 32 and we save it as f, like that. There. Okay, so with this float 32 which I've created, we want to change it to become a float 64. So you can always do that, but for you to do that, so you use this function as array, then you give it the array whose type you want to change, then the data type you want to change it to 64, and how it's going to be saved. So we want to save it back into f like that. So in this case, when you change the type, now it's a 64, and you print out f like that. So basically there doesn't seem to be much difference, but the difference is in how the data is stored. Okay, you can also change, for example, this same, the one we have here, you can see the numbers are stored as decimal points. With decimal points, you can change it, say you want to store the numbers as integers. So in this case, you say np.asArray, then f, d type, then int 8, then f there. You save it as f. So in this case, you have your data type, now it's an int, then there. So you can see the decimal points has been changed, have been removed. So basically that's how you would change the type. Okay, you would change the type of the data which is contained in your array using casting, using as array. You can use the as array method. Is method a function? No, as array function. It says method. It's supposed to be function. With Numpy, yeah, with as array function. That. Okay, so that's one way of doing it. Are we clear on what we have said? We're doing here. Is it clear?
It's clear.
Okay. Next, there's another way again. You can change the type of things you have. For example, we have our f now. F matrix is this one. Then the type is an integer. But we can decide, you can use this one as type also. As type does something similar. So f.asType, you can change it to 32 and you store it as f like that. Then you print out your f there, and the type is 32. So there are two ways in which you can change the information which is contained in your array. So basically these are some of the things. This is not everything. These are some of the things you can do. Okay, these are the bits for fancy indexing. I need to fancy indexing is accessing things. So here we create an array of numbers from 0 to 5 here, then you display this. So that's what you have here. So 0 up to 5. I can use this array of 0 to 5 to access the diagonal elements, because it's 0 0 1 1 2 2 like that. So I give two two arrays, this and this one. So this is going to give me access to the diagonal elements, which is 0, 11, 22, 33, 44, and 45. Or I can also change the diagonal elements. After accessing them, I can change the value of the diagonal elements to a value of 2, like that. Then next, after doing that, if I display the diagonal, then you can see that the diagonal has got its values changed to 2. If I display A there, you can do that. Okay. Again, here, there it is. I can, if I want to access what I did, the diagonal, but the row or whatever it is above the diagonal. So I add a +1 here. If I add a +1, so that is what we did with the offset set equals to 1. If you want to do something like that, this is what you can get. If you want to set the values there to some value there, then you can do that. And if you can want to access those values, now you can see that those values are all set to 5 here. These values are all set to 5 there. So you can change, like you can manipulate diagonals like this. Of course, here again, I plus 1. Which one is this? 10, 20. Yeah. So basically, yeah. So the lower diagonal in this case plus 1. So this I plus 1 gives you access to the lower diagonal, which is this one: 10, 21, 32, 43, 45, 54, which is what we have there. Of course, you can change those values to 3, all of them. Then you can print out your thing. So here, you go to 3 here, you go to 3 there, you go to 3 there, you go to 3 here, you go to 3 there. That's something you can do. Then you can also access those values as 3. So basically, that's a bit on fancy indexing. Nothing really much. It's basically just a rough way of accessing diagonals. But I think whatever it is, that I think anyway, yeah. Okay. Any questions? Or this bit?
So far so good.
Okay. This bit comes to an end here. Like I was saying, I'm hoping that you finish in 2 hours. So the next, yeah, if you want to take a break, let me give you 10 minutes break. So you come back at 16:10.
Thank you, sir.
Okay, fine. Have a 10-minute break, then you come back.
Okay.
All right.